Okay, so at the top of your paper, you should have the words triangle inequality theorem. And today, we are working to see if we can make triangles. Now, the first thing I want to ask you is the angle measures of a triangle. How many degrees are the three angles inside of a triangle? Does anyone remember that? If I add up the three angles inside of a triangle, how many degrees would that be? Mickey. All together, all three angles add up to what? Okay, so on your paper, I want you to draw a triangle. If you add up angle 1 plus angle 2 plus angle 3, they all add up to 180 degrees. The angles in a triangle add up to 180 degrees. So if I add angle 1 plus angle 2 plus angle 3, they add up to 180. That can be any numbers. It could be 40, 50, and 90. 60, 30, and 90. I mean, they could be all three numbers could be different as long as all three add up to 180. Okay, that's one part of the triangle. Now, the other part that we're working with today that's brand new, because this is something that you should already know prior to 7th grade. That's not new, knowing that a triangle adds up to 180. That's something you learned in elementary school. So that's not the new 7th grade material. The new 7th grade material deals with the sides of a triangle. That means the lengths of the sides. Okay? And we're going to look at a quick video together to see how we can determine if three different sides will make a triangle. We have a lady, as you can see here, and she has these different size little sticks. Okay? And she's going to be using those different size sticks to see what will make a triangle and what will not make a triangle. And I'll be pausing it and we'll talk as she's working. But we're talking about the side lengths. If I give you numbers like if I say if a triangle has sides of 7, 5, and 9, will that make a triangle? Can you answer that? You will be able to answer that by the end of class today. That's what we're looking at, are the side lengths of the triangle. Okay? So we're going here.
Right. Now, sides of triangles are line segments, and here we have some, not exactly line segments because these guys have thickness, and line segments only have length but no thickness. But in order for us to see the line segments and move them around and have dimensions on them, they do have this thickness, but we're just going to have to imagine. All right, so my question to you is, if I choose 3 of these line segments, could I form a triangle? These are 2 inches, 3 inches, and 4 inches long. So 2, 3, and 4 inches.
Okay, did it make a triangle? A 2, 3, 4. Okay, so on your notes paper, I want you to write down 2, 3, 4, and put yes. 2, 3, 4. It made a triangle. 2, 3, 4. If we have a side length of 2, a side length of 3, and a side length of 4, it makes a triangle. And the question is why? Why does that make a triangle? That's what we're looking for, because when we work on these, we don't have time to cut up strips and actually put strips together and see if it works. There has to be a mathematical understanding as to why a 2, 3, 4 works. Okay, let's look at another one.
And we can see here that even with thickness, yes, we have a triangle. All right. So, and of course we know our 3, 4, 5-inch triangle should give me a nice right triangle here.
Okay, so write that one down.
3, 4, 5 triangle.
3, 4, 5, it's a yes. 3, 4, 5, yes.
What about if I'm just going to pick 2 4s here. Now, can I put a 2-inch side between them? There we go.
So the 4, 4, 2 work? So 4, 4, 2, that's a yes, it works. This is called an isosceles triangle. Why is that isosceles? That's right, isosceles. The way I used to remember that when I was in school, I had a teacher, or maybe myself, I think I kind of came up with it. I-S-O-S, see how it has those two S's? C-E-L-E-S, isosceles, the double S, two sides that are the same. Okay? That's an isosceles triangle. And we'll be talking about the different types of triangles today. So a 4, 4, 2 works. Anybody have an idea as to how this is working yet mathematically? Anything special about the numbers? Yes. Okay.
4, 4, and 2 form a triangle. What about 4, 4, and 3?
Does 4, 4, and 3 work? Okay.
That looks good too.
So 4, 4, and 3 work. I don't know. Maybe. Let's see. There may be a pattern.
What about 4, 4, and 5?
Does it work?
Another triangle.
Okay.
But you see the shape of our triangle is changing while they're all isosceles. This, I think our next one is...
So 4, 4, and 5 work. Okay, you ready for the next one? Let's see if it works.
It's going to be an obtuse isosceles. And this is 4, 4, and 7.
So 4, 4, 7. Does it work?
Yes.
Okay.
Now, I think you can start seeing that there will come a time when this side, if I have 2 4-inch sides.
What's happening now? What's happening?
She has 2 equal sides, and one of them has to be opposite.
Okay, let's keep watching.
This side will be too long.
Do you hear what she said?
And my question to 7.
Watch.
Now, I think you can start seeing that there will come a time when this side, if I have 2 4-inch sides, this side will be too long. And my question to you is, when will that happen?
What do you think? When will that side be too long? Huh? What number could we put on the bottom that would make that side too long?
9.
What? 10? 9?
8. 8.
8? Okay. So let's see.
If I have a 10-inch side, will I be able to form a triangle with 2 4-inch sides? And the answer is no.
So write that down. 4, 4, 10. That is a no. Why is that a no? Because if we don't have the sticks, if we don't have those sticks to do this, mathematically, why is that a no? Yeah, but we can see that though. If we couldn't see it, how would we know just using the numbers?
2 4-inch sides would add up to equal 8.
Okay?
10-inch side is bigger than 8-inch side.
Yes, sir. Y'all give Jawan a hand. Got it. That's exactly right. These two sides, the two smaller sides, have to be bigger than that remaining side. So when you add up the two smallest sides, their total must be larger than the biggest side. So 4 and 4 gives us 8. 8 is not bigger than 10. Therefore, this doesn't work. That is the triangle inequality theorem. So let's write that down. Add up the two smallest sides. The total must be greater than the remaining side. That is the triangle inequality theorem. Good job. Okay. So here's what I want to do next. We're going to actually put this into action and see how it works. So you're going to get this sheet that you see on the screen. Okay, so on this sheet, we're not going to fill in every single column, okay? We have a triangle with side lengths of 10, 9, and 8. And like I said earlier, we don't have those little strips that lady had to sit here and visually see if it works. So we have to know the mathematics behind it. And Jawan helped us to figure out the mathematics behind it. Okay? So we're going to find in this list of 10, 9, 8, what are my two smallest numbers in that list? Circle them. Circle 9, circle 8. We're going to add those together. What is 9 plus 8? So we're going to X these out. We're not going to use any of these boxes right here. Okay? So if we add 9 and 8, that gives us 17. Okay? Now, what's the last side that's left over that we did not use? Is 17 bigger than 10? So yes, it forms a triangle. Okay, next one. 10, 6, and 3. What are my two smallest numbers in the list? So we're going to circle them. That gives us what? 9. So is 9 bigger than 10? No, so no, it cannot form a triangle. We can just X out all these boxes right here. So we're not using them. Okay, next. We have 10, 6, and 4. Which two numbers do I circle? What are my two shortest sides? Okay, if I add those up, I get 10. Is 10 bigger than 10? No, so it cannot form a triangle. No, it can't be the same. It has to be bigger. Okay, next, 10, 6, and 5. What two numbers do I circle? And what do we get? Is 11 bigger than 10? So that's a yes. 9, 6, and 3. What do I circle? What's the total of 6 and 3? Is 9 bigger than 9? Nope. Okay, next, 9, 7, 4. And we get, is 11 bigger than 9? That's a yes. Okay, 8, 5, and 3. That gives us, is 8 bigger than 8? 8, 5, and 4. Which gives us, is 9 bigger than 8? 7, 6, and 3. Which gives us 9 bigger than 7. Okay, last one, 8, 7, 5. Which is 12. Is 12 bigger than 8? Okay, excellent job. All right, the next sheet I'm going to give each person is this page right here. It has notes on it and the second page. We're going to work on page 1 and page 2 together. So I'm going to come and give you one of those sheets. Okay, in this packet, the first thing you'll see is that we can name a triangle by its sides. We have isosceles triangles, which you heard the lady talk about. 2 sides are equal. We have scalene, no sides are equal. We have equilateral triangles. That means all 3 sides are equal. Those 3 names you should be familiar with. That's not new 7th grade material. That's elementary. Do you understand? The other 3, you should be able to look at a triangle's measurements on the inside and determine if it's an acute triangle, because all 3 angles are acute. Obtuse means you have one obtuse angle, and we all know right triangles because we know the little box here. Okay? That is also old material. That's not brand new. The next thing you see on your paper is the triangle sum theorem. Angle sum theorem, and we've talked about that. All 3 angles add up to 180. That's not new. The only thing that's new is right here, the triangle inequality theorem that we've talked about today, which means that if you add up the 2 shortest sides, that total must be greater than the remaining side. And then this is new right here. And we'll talk about uniquely, not existent, and ambiguously defined a little bit later today. Okay, let's start here with number 1. We have triangle ABC. They tell us that angle A is 74, angle B is 66. They want us to find angle C. We don't know what it is. How do we solve for angle C? What do we need to do? Okay. You're exactly right. So we're going to add up 74 and 66. Everyone should be doing that because you have a calculator. What does that give you when you add those together? And what do we do with 140? Why 180? And look right here, see the formula? There it is. Angle A plus angle B plus angle C has to equal 180. It's written right there. So the missing angle is what? 40 degrees. Now the next question says what type of triangle is this? If we know we have a 74, a 66, and a 40, what type of triangle would that be? Acute, because we have 3 acute angles. Good. Okay, second page. Okay, for this one, angle A is 49 degrees. Angle B is how many degrees? Huh? I can't hear you. 90. How do you know it's 90? It has that little box. So now we have to figure out C. Yep. Add them up. Angle A is 49 plus angle B is 90, and we don't know C. So what do we get when we add those up? 139. Well, now what do we do with that? And what do you get? 41 degrees. What type of triangle is this?
Right.
A right. It's a right triangle. Okay, next, number 3. Angle A is 47. Angle B we don't know. Angle C is 26. Figure out angle B, please. Okay, what do you get? 107. Good. 107 degrees. And what type of triangle is this? Obtuse. Good. All right, number 4. Look at this one. Angle A is 2x, B is 52, and C is 42. How in the world do we approach this one?
You have to add B and C and then times it by 2.
Good try. Let's plug it into the formula here. Angle A is what? Plus angle B is, plus angle C is, and it equals 180. Now what do I do? Those are like terms. So add those up. And what do you get? Huh? 94, so I get 2x plus 94 equals 180. All right, what's next? So I gotta solve it. So I do what? Subtract what? Subtract 94 on both sides. These are things you have to know how to do. At this point, if you can't solve an equations, milestones is not going to go well for you. That's the bare minimum. If you are clueless on how to solve 2x plus 94 equals 180, you should be concerned. Big time. You should be able to solve that with no questions and no help at this point in the year. Okay, so 180 minus 94, and you get is equal to 2x. Okay, what's next? Divide by 2, and we get x is equal to
43.
Now, is angle A 43?
Yes.
No. Angle A is 2 times x. What is x?
43.
So we have to do 2 times 43 to figure out angle A, which is
86.
86 degrees. See what I'm saying? Solving it is not the issue here. You got to solve it and know what to do with the answer to finish this problem out. That is 7th grade work. It's not solving it. Solving it's the bare minimum. You got to know what to do with that answer after you solve it. Okay? Now, what type of triangle is this? We have 86, 52, and 42. Acute. All right, number 5. Angle A is what? Plus angle B is, what's angle B? 90. Plus angle C is equals 180. Okay, now what do we do? Do what? Combine like terms, so 2x plus 2x gives us 4x plus 90 equals 180. Okay, so what's next? Okay, draw a line. Subtract 90 on both sides. Okay. And here we get 90 is equal to 4x. Okay, then what do we do to both sides? Divide by 4. And we get x is equal to 22.5. Is that my answer for A and C? What do I have to do? I gotta do 2 times 22.5. It's 2 times x. What is 2 times 22.5? So A is 45 and C is 45. And B we said was 90. Okay, what type of triangle is this? All right. Good job. Okay, let's go to the bottom. All right. Now, if you look back to this box right here on your front page, put this beside you because we're talking about this box right here. That ambiguous, non-existent, and unique. Now we're getting ready to talk about these 3 words. So put that side by side with your sheet so you can keep referring to that chart. Okay. First of all, they gave us 3 angle measures. And the first thing we have to do is figure out if 53, 62, and 65 make a triangle. So how do we figure that out? What do we do with those 3 numbers? Add them up and see if they add up to what? Okay, do that. Do they add up to 180? So it makes a triangle. Now, just because it adds up to 180 doesn't mean we know what size it is. Do we know the side lengths? Can we have different side lengths? Because don't all triangles have to add up to 180? Yeah, but we can have a 3, 4, 5. It could be a 5, 6, 7. It could be a 7, 8, 9. It could be a 4, 4, 3. It could be a 4, 4, 7. It could be a 4, 4, 8. All we know is that those 3 angles add up to 180, but we don't know the sides, which means that this can make many different triangles. It can make a lot of different triangles. And if you look back at your front sheet in that chart right here, when we know that there are 3 sides, this should be a 60 on my paper like yours. When we know those 3 angle measures add up to 180, then many triangles are possible. And the mathematical word that we use to define that is ambiguously defined. And there's the word ambiguous, so you know how to spell it. That means, hey, the 3 angles add up to 180, and the sides can be anything. So that's ambiguously defined. So on that line, we're going to write ambiguously defined. Or you can just put ambiguous triangle. Because we can make many different triangles because those angle measures add up to 180. We just don't know the different side lengths. They can be all different side lengths. Okay, next one. A triangle with side lengths 7 centimeters, 12 centimeters, and 18 centimeters. This time, we have to use our triangle inequality theorem to see if it makes a triangle. So what 2 sides are we going to add together? 7 and 12. What does 7 and 12 give us? 19. Is 19 bigger than 18? So it forms a triangle. And guess what? We can only make 1 triangle with this one. Why can we only make 1? Why can we only make 1 triangle here? Well, we know it makes a triangle. And we know the exact side lengths. We can't make a different side length triangle. It can only be a triangle that's 7, 12, and 18. That's it. Because it gave us the side lengths. So this one's called unique. Unique. You can only make one triangle with this because it gave us side lengths that work. Okay? We can't do more. Okay, next, a triangle with side lengths 4, 8, and 10. 4 and 8, which gives us, is 12 bigger than 10?
Yes.
Yes, so does it make a triangle? We can only make one triangle. It's unique. We can't make any more because we know the side lengths. It's when we don't know the side lengths that we can make a lot of different triangles. If we know the side lengths, you can only draw one triangle. That means you would take a ruler and you would measure out 4, you would measure out 8, and you'd measure out 10. And it would make one triangle. There's only one way to make that triangle. That's it. Does that make sense what I'm saying to you? Okay? All right, next, a triangle with angle measurements 83, 92, and 105. So how do we test this? Add them up and see if we get 180, right? So can we make a triangle? So guess what this word will be? Non-existence. Next one, a triangle with side lengths 3, 6, and 9. So we have to test it. What two numbers do we add together? 3 and 6, that gives us, is 9 bigger than 9? So can we even make a triangle? So this would be non-existence. Okay, next, a triangle with measurements 83, 60, and 47. So go ahead and test it. Can you make a triangle there? Huh? Nope. So this would be, what was your total? 222. Too big. Has to be 180. It was what? 83 plus 60 plus 47 is 190. Yeah, that's 190. Okay, so that wouldn't work. Okay, next one. Triangle with side lengths 11, 15, and 16. So what two sides do we add together? 11 and 15, which gives us, is 26 bigger than 16? So it forms a triangle. How many triangles can you make? You can only make one. So that would be unique. Okay, next one. We have a triangle with side lengths 5, 5, and 12. What two numbers do I add together? Which gives us, is 10 bigger than 12? So that would be non-existence. Okay, last, a triangle with measurements 100, 60, and 40. Yep, that's 200. So that's going to be non-existence. Excellent job. Are we clear on that? We good? Okay. Put this into your notebook along with your notes. At this time, you're going to work on this sheet right here that you see on the screen. I'm going to come around. Oh, not that one. I apologize. Hold on. This one right here. Everyone is going to get one of these sheets right here to work on. It's the triangle inequality theorem where you add up your two shortest sides and you put yes or no. Okay? You're going to work on that at this time.